The problem here is to design a voltage adapter for an IT equipment. The equipment can operate on DC voltage from 16 to 22 volts. Firstly, let's look at the design procedure we suggested in our tutorial. The first step generally is to translate problem statement to design specification. There may be many candidate circuits available. We need to choose the prototype circuits appropriate for our design. The next step is to design the prototype circuit. That is to specify all the component values in the prototype circuits. After we design the circuits, we need to analyze that, see if it meets the design specification theoretically. The last part, we need to build the circuit and test it, check with the design specification. So firstly, let's translate the problem statement to design specification. In this problem, we want to design a power supply voltage adapter for an IT equipment. The equipment operates on 16 to 22 volts DC. So we want to design an IT voltage adapter. The input should be 120 volts AC. The output should be DC voltage from 16 to 22 volts. So generally, when we design an adapter, we need a transformer to convert the voltage at 120 volts to a lower voltage. So the transformer can convert the high voltage to lower voltage. Then we need a voltage multiplier to convert the AC voltage to DC voltage. In this problem, we need to make it 16 to 22 volts DC. So the transformer circuit, let's look at the transformer circuit. Input is 120 volts DC. The output here, actually we can convert it to a low voltage. For example, 6.3 volts AC. So we can easily find a 6.3 volts transformer easily. So the output here may be 6.3 volts, but it's still AC voltage. So we need a voltage doubler or voltage multiplier to convert the AC to DC. So if it's 6.3 volts AC, 6.3 is the RMS value. So the maximum magnitude, the peak value should be square root of 2 times RMS value, 6.3. So that's around 9 volts. So the peak value should be around 9 volts. So the output from the transformer is AC voltage at 9 volts peak. So if we have a voltage doubler, it can convert the AC voltage to 18 volts DC. So that should meet the design specification. So here, the first step, we can use a 6.3 volts transformer here. So input is 120 volts AC. Output is still 6.3 volts AC. So the voltage doubler will convert the AC signal to DC voltage. So let's look at the circuit here. 6.3 RMS value. So the peak value should be 6.3 times square root of 2. That is around 9 volts. Let's look at the negative half of the waveform, the period, from 0 to t over 2. So the top is the negative terminal. Here is the positive terminal. So that's for the negative half period. So the current flows in this direction. So this diode should be on, and it's going to charge the capacitor to its peak value, 9 volts. So I just specify the polarity of the voltage here. This diode is on. Let's look at the negative half of the period. So the positive terminal should be on the top. Here's negative. So right now the capacitor has been charged to 9 volts, and this dial should be off. So here's off. 6.3 volts RMS is the same thing as 9 volts peak. When we look at the voltage across these 2 points, so it should be 9 plus 9. The maximum value should be 9 plus 9, that is 18 volts. So it's positive on the top, negative at the bottom. So total is 18 volts at a maximum value. So look at the polarity. The current will flow in the clockwise direction. So this diode is on. So it's going to charge this capacitor to its maximum value, 18 volts. So at the output terminal, we will get 18 volts DC. So in this design, we need a 6.3 volts transformer, and we need a voltage doubler to convert the 6.3 AC voltage to 18 volts DC. So let's design the prototype circuit. For the voltage doubler circuit, we have just analyzed the capacitor voltage is around 18 volts. For the diodes in the circuit, so here for the diode, the reverse voltage maximum should be at least 18 volts. So here is around 18 volts. So we need to pick up the diode whose reverse voltage is greater than 18 volts. So let's look at the IN914 diode from the Radio Shack. So for 10 diodes package, it's only $1.49. So let's look at the details. The continuous reverse voltage maximum is 75 volts. So it seems to be okay for our design. So we have a 10 diodes package. It's only $1.49. So let's use two IN914 diodes. We specify that as D1, D2. For the two capacitors, the maximum value should be at least 18 volts. So let's use 10 microfarad at 35 volts. We need two electrolytic capacitors. And we also need a 6.3 volts transformer. So that's the 5 components in our circuit. The next step, we need to analyze the design circuit to meet the design specification. So the first part, ideally the input is 120 volts AC. The output is 6.3 volts AC. So the amplitude, the peak value should be 6.3 times square root of 2. That is around 9 volts. The voltage doubler will convert the 9 volts peak value to DC signal at 18 volts. So at the negative half of the period, this diode is on. D1 is on, so it's going to charge D2 to its maximum value, 9 volts. So in the positive half of the period, so the 9 volts capacitor, the voltage across the capacitor C1 and the voltage across the transformer output, they're in series, so totally 18 volts. D1 is off, D2 will be on. So D2 will be on because the current flows from left to the right. So it's going to charge capacitor C2 to its maximum value 18 volts. In our design specification, it calls for 16 to 22 volts. So it's going to meet the design specification. The next step, we need to build the circuit and test it. Here's our voltage doubler circuit. So here is the output from the transformer. It's supposed to be 6.3 volts AC. The output of the voltage doubler should be 18 volts DC. We have two diodes and two capacitors in the circuit. And input to the voltage doubler is the output from the transformer. So here is the transformer circuit. The output is 6.3 volts AC. The input is 120 volts AC. So let's show the output of the voltage doubler on the oscilloscope. So we show both of the input to the voltage doubler and the output of the voltage doubler on the oscilloscope. So the bottom waveform is the input to the voltage doubler. That is a AC signal. The top waveform is a DC signal. That's the output from the voltage doubler. Let's look at the average of channel 2 is around 20 volts, 19.999 volts. And peak value is only in 200 millivolts. So that is DC signal at 20 volts. So the DC voltage exceeds 18 volts. That's because the transformer output is a little bit above 6.3 volts AC. So let's check the design specification. So here the output is 20 volts DC. The design specification calls for 16 to 22 volts. So that meets the design specification.